Problem 24. Define a sequence recursively by x naught equals 5 and x sub n plus 1 equals x sub n squared plus 5xn plus 4 divided by xn plus 6 for all non-negative integers n. Let m be the least positive integer such that x sub n less than or equal to 4 plus 1 over 2 to the 20. In which of the following intervals does lie? A, 9 through 26, B, 27 through 80, C, 81 through 242, D, 243 to 728, and E, 729 to infinity. And so notice that these intervals are actually quite big. They're like each a factor of 3 wide, which is quite loose. And motivated by this, we can probably guess that x sub n equals 4 is a fixed point. So basically, you should be able to guess that when you plug 4 into this recurrence relationship, you'll get 4 back. Wait, we can also factor this. So xn plus 6 times xn plus 1 times 6. So if we were to plug that in, we would get x sub n plus 1. If xn equals 4, then this equals 4 plus 1 times 4 plus 4 over 4 plus 6, which is equal to 40 over 10, which equals 4. Nice. Okay. So we are now very confident that like x sub n equals 4 is a very important spot. And so now we use a technique I don't really know what this technique. Yeah, we substitute now y sub n equals x sub n minus 4. Because once we do this, for example, we can, take like log of y sub n, and this will actually mean something. Because we're trying to because otherwise, if we don't do this substitution, then we're just getting closer to 4, but it's hard to tell the difference between being like 1/10 away from 4 and 100th away from 4. And so once we substitute that in, y sub n plus 1 is equal to x sub n plus 1 minus 4, which is equal to x sub n plus 1 times x sub n plus 4 over x sub n plus 6 minus 4, which is then equal to y sub n plus 5 times y sub n plus 8 over y sub n plus 10 minus 4, which equals y sub n squared plus 13y sub n plus 40 over y sub n plus 10 minus 4y sub n minus 40, which then equals y sub n squared plus 9y sub n over y sub n plus 10, which you can pull out a y sub n from the top, which gives you y sub n times y sub n plus 9 over y sub n plus 10. So basically, we have figured out for y sub n what the next value of y sub n is going to be, and this is quite a clean formula. And in general, we have that y sub n is going to be in 0, 1, because x naught equals 5 implies that y naught equals 1. And it's only going to be going down from there because this is less than 1. And in fact, not only is this value less than 1, we can estimate this as being less than 10/11ths and greater than 9/10ths. So yeah, we have that estimate. And since the margin is a factor of 3, it doesn't really matter. I'm just going to assume that this value is going to be approximately 9/10ths most of the time. Okay. And so now we estimate how long it takes until y sub n is less than or equal to 1 over 2 to the 20. So notice that 9 over 10 squared Oh yeah. So based on the 9/10 approximation, you can say that y sub n plus 1 is approximately equal to 9/10 to the n. Yeah, it's just equal to that. And so we have, in order to find how long it takes for it to be below 2 to the 20, note that 9/10 squared is equal to 81/100, which is approximately 4/5. And 9/10 to the 6th is approximately then therefore equal to 64/125, which is approximately 1/2. So that means that like the half-life of y sub n is 6 terms. So it takes 6 rounds for y sub n to go down by a factor of 2. And if we have to do that 20 times, that will take 120 rounds. And that is smack dab in the middle of the interval C. And so we can be pretty confident that the answer is C.